In this video, I am going to share how a current carrying loop behaves as a magnetic dipole. First of all, let me share what is the meaning of a magnetic dipole. A simple magnet having south and north poles. Strength of a magnetic dipole is measured in terms of magnetic dipole moment. It is denoted by a capital letter M and it is a vector quantity. Magnetic dipole moment of a magnetic dipole is defined as the product of M and L vector. That is small m. Small m stands for pole strength of either pole of the dipole, and L stands for separation between two poles of the magnetic dipole. And L is taken as a vector quantity. Its direction is from south pole towards north pole of the dipole. And magnetic field or magnetic lines of force of a magnetic dipole are shown in this figure, and these lines start from north pole and go towards south. Means magnetic lines leave the magnet from north end and enter the magnet from south end, and these lines are continuous lines. They also pass through body of the magnet. So this is a current carrying loop. I have taken the example of circular loop. It can be of any shape. This current circular loop has been connected to a battery through which current, as shown by red arrows, flows. As it is clear from the diagram that current in the loop appears to be flowing in clockwise direction. And it has been observed that magnetic field is developed around this current carrying loop, and magnetic lines enter the loop from front side and leave the loop from its back face. If I compare the magnetic field due to this current carrying loop with that of a magnetic dipole, it is very much similar. In case of magnetic dipole, magnetic lines enter from south pole and leave the magnet from north pole. Similarly, magnetic lines enter the current carrying loop from front side and leave the loop from the back side. So if we compare the current carrying loop with a magnetic dipole, it can be stated that front face of the current carrying loop behaves as a south pole of dipole and back face behaves as north pole of the south pole. So current carrying loop behaves as a magnetic dipole. Let me summarize the whole story that current carrying loop acts as a magnetic dipole. It is clear from the previous discussion that front face of the current carrying loop through which current appears to follow clockwise direction, that face of current carrying loop acts as south pole, and the other face, that is back side of the loop through which current appears to be anti-clockwise, it behaves as a north pole. As current carrying loop acts as a magnetic dipole, it must also have some magnetic dipole moment. Magnetic dipole moment of a current carrying loop can be expressed as the product of current I and area A. What is I? I is current flowing in the loop and A is the area enclosed by the loop. It is also a vector quantity. In vector form, I can write M vector is equal to I multiplied with A vector. Now next question is how to find direction of magnetic dipole moment of a current carrying loop. This figure shows that if we curl the fingers of our right hand in the direction of flow of current, then thumb points in the direction of magnetic dipole moment or area vector enclosed by the loop. This is how we can find direction of magnetic dipole moment. Thanks for watching this video.